but there is only 7 from the Tuesday group. Okay, so this afternoon you are going to show up who is there. Okay, if there is an exam, there is an exam. I can't do anything about it. Those who do not have an exam and are free, send me an email that you are attending this afternoon so that I can prepare my comments and discuss with you some of the corrections. I want you to do it yourself. It won't take very long. Then only I can cut it. Okay. Uh, to be briefly going over what I have found, it ranges for different people. It is different problem, but one problem that is common to everybody. Okay. Let me pull the first. Which one is it? I don't know whether it's this. Already loaded everything and then I think they got wiped out. Okay, I have a video. I think it is this. Okay, let me go here. Do you see it? The video of flipping on the screen? Yes or no? No.
No.
Just a minute. Okay, I am seeing it right. Okay, do you see this screen? The PPT file?
See the PowerPoint.
Yes, okay. Okay, let me describe to you what the problem that I find in most of the files before I move on. So it's up to you to correct it if you want before coming to the lab and then review it with me if you have time, or do it during the lab time. Okay, so let me go to okay, done. Okay, so when I take the part, rectangular or no square block on which done both sides, 18mm nominal. Okay, so some of you have done reduction straight, taking 2 millimeters off side 1. Some have distributed it 2 sides. Take something off on the first side and machine, flip and go. Okay, if you look at the part, there are altogether 4 holes. Drilled plus 2 more pocketed holes. Then there is a center hole. Okay, are you seeing my screen? Yes?
Yeah.
Okay. Now, most have drilled these 4 holes all the way through, as well as this, as well as this, as well as this. Okay, yeah, problem. Some have not drilled this hole at all. That means when you flip, you can't even lock it. Okay, so that is number 1 problem, this hole not being there. Number 2, drilling these or pocketing these 6 altogether, all the way to z equal to 0. What will happen? When you cut it through, vacuum is lost. Vacuum will be lost. I have not machined. That's the reason why I have not machined. When you are doing all this on side 1 and you cut it through even the very first hole you pound, okay, let's say this hole, immediately the vacuum will be lost. Even the vacuum is there, is all going to leak through this. That means the part will not be held. So I said leave a skin so that the vacuum doesn't break. Okay? Now, leaving a skin, how much? Depends on whether you're machining on both, in one shot or machining on both sides. Okay? Why? Why would it make a difference? Let's say I am starting with a 13 millimeter stock and I go z equal to 0. That's the first problem, right? Vacuum will leak through. The next option is to leave a skin. Okay, how much is this depth that or height or thickness that you should leave a skin? Okay, if you leave a 1 millimeter, okay, that's okay for the side 1. When you flip and you had another face milling that you're going to do of 1.5, all the holes that you have cut will be exposed.
Dr. Balai.
Okay, now we should be okay. When
Yeah.
did I lose you? Or
Second ago.
okay, just now? Okay. So I will just go through the last 2 minutes. If you cut it all the way, these holes, vacuum is going to be lost. It applies to all the 7 holes that normally will go through. This must be present and should not be cut through, because when you flip and lock it on to the tab, if you leave a little skin, okay, that vacuum will not leak. It's required, and this is recessed quite low so that it doesn't affect the face milling. So I would say, as far as I'm concerned, you should check if your Z is shown as equal to 0 for all this. You have to modify, and also you should add this hole on the first side, not on the second side. It's of no
Just a
use.
question, Dr. Bala, but
Ye-
um,
yes. Yes.
isn't it very inaccurate to drill holes from two sides?
No, you don't drill from two sides. Okay, so I accept if you leave a tiny little skin, let it be there. Okay, this is the problem with the vacuum machining with vacuum holding like what you have. If I had a strategy of, which is what until 2 years ago was done, is to hard clamp onto a plastic base. Okay, then you can punch through. Okay, there is no vacuum whatever. You drill through from straight one side. Okay, here what I'm saying is you don't go and drill these holes from the other side also. Just leave a little skin. You estimate based on your strategy. Should I go z equal to 3 or z equal to 2.5 or z equal to 2? And you don't machine those holes from the other side. Yeah, just leave them. There will be a tiny little skin, and if it is a 0.5, 1 millimeter thick skin, you can literally clean it off with a little uh, sharp tool. Okay. Yeah, you're not machining from both sides. You're not going to repeat the machining of those 6 from the other side at all. Is that clear? Whoever asked, is that clear? Am I losing you guys? My audio is not going through or what? Somebody asked about whether you're going to be machining from both sides.
We can hear you loud and clear, Dr. Bala. It's just I don't think we're able to wrap our head around it.
Yeah, but somebody asked that question. Is it clear why I'm not expecting you to machine from both sides? Okay. Hope it's clear. Okay. Next problem that I see, it is only for one person. Viewed from the top. This is top view of the stock. Okay. When you're doing face milling, make sure the entire part is covered. If you leave a little ridge here and leave a little ridge here, not good, because there is a little ridge on the top of the part, because the face milling went like this and it didn't go overlap this much, so it left a little ridge on this side, and it also left a ridge here. What will happen? When you flip this part, it is not going to sit tight on the flip side of the fixture. That means the part is not going to be accurate at all. So during face milling, make sure the entire top is taken off, face milled. I think it has happened in 1 or 2 cases. You have to check. Okay. What would be another problem that I have seen one? Okay. Now, when you have the part, should take another slide. Okay. When you have a part with the details, 4 holes, another hole, and then you have all these little details of the 320 degrees crevice onto which your lamp base is going to lock. There is a tiny little ridge. Now, 2 things that I have seen. On one side, it is correct. When you flip and whatever you have drawn, when it is machined, the holes are out of phase, right? Shifted from here by probably 60 degrees, 30 degrees. I'm not sure what it is. I'm not measured. That means you do not have underneath this ridge, you have material you can't lock because that notch has gone elsewhere. Why would that happen? If your rotation, when you added the second side machining, is not right, something has gone wrong. In fact, I machined one, which I could not see on the simulation because it's done by one, but when it actually machined, I have the part downstairs. Nope, that's the problem. Okay, so that's another one. Another issue that I have seen, okay, is this. If the stock is assumed as some have assumed as 13.5, strictly speaking, it's 12.7, but doesn't matter. Then you are going face milling from 13 to 11, 13.5 to 11. So this is 2.5. You've assumed the stock is, okay. Then when you flip, again, you're doing 13.5 to 10. Okay. So strictly speaking, you have to define the stock as now, if you have reduced from 13.5 to 11, this should be 11 to 10. Otherwise, you are wasting 2 cuts in the air for facing, plus rest of the machining is also going to start adding up because you are doing some wasted cuts in the air for between 13.5 to 11. This I have seen a couple of places. So all this will consume more time in machining, plus the first problems that I talked about is going to not, that's why I didn't even venture yesterday. Yesterday I was in the lab, hoping to run all the 8. Dry run, nope. I discovered all these problems. I just looked at the notes. Nope, I am not going to machine. So I stopped. So what I would suggest is somewhere here, there are 3 submissions that are not there from Monday, not Monday, Tuesday group. So you should first finish off. Those of you who have not given it to me yet, you should finish off, or I can look at it. The other 7, totally 10 submissions, out of which 3 is from BO2. I have all the programs from BO2, even though it has got problems. BO1 should be 7 out of 10, correct? So 3 is not there. I have the names in one of my files. Okay, so that's what is going to happen today, this afternoon. I will be conducting the lab. I'm going to be on the WebEx. I am not going to be in the lab, so I would not be machining anybody's until everything is sorted out. Okay. Dan, how are we going to proceed? Well, I don't really know whose exam schedule is what. Officially, I don't know how many more people are finishing it by the end of this week. Next week is open. I am going to ask you next week. I want to finish all the machining before you go away for break so that you can finish off the report. So your report should be in when we begin the next term, at the very beginning, because it takes me time to correct all of them. But I will tell you the date next week. But Oru is there next week, free to attend the lab Monday through Friday, all days, only in the afternoon, not in the morning. Okay, send me an email. I will tell you on the Thursday class after I review all of it. I can cut 1 or 2 per day, or even 3, depending on no issues at all. Right? So that's what I wanted to tell you of front, as well as I am going to send you an email about this revised midterm plus final combined last week. I did ask for feedback. All 10 who were there said yes. I'm going to formally ask you to say yes through email. Okay. Any questions? Okay. A Thursday class, I want to check. It is not PM, it is AM for the lecture. Presumably they were going to close the WebEx, D2L, everything on the 16th. There was a little wake up from a lot of people. Something was done. My schedule was lost, that process, but I restructured, and I don't know where that AM PM screw up happened. Anyway, anything else? Now I'm going to go and finish up this section. Okay, my screen is still up. PPT file. Yes, somebody please. Okay, so we looked at the slide before it was the furnace control. Okay, so after going through all the hardware, this is the final result. Whether it came from TT or truth table or through the logic analysis that I did, the result finally before it goes to the PLC must be in this form. So transferring the equation, power and flame, or ignition being on, open the gas valve. Power and no flame and no alarm. That means alarm is coming as an input. Ignition should be switched on. Power and no flame. Start a timer for 5 seconds. And if the timer persists, set an alarm. Okay, that's 1, 2, 3, 4, possibly one more line to make the program end. 5 lines of code will control this furnace. Or it could be described as 1, 2, 3, 4, 5 rungs. 1 rung, 5 lines, or 5 rungs. That's what the program is. Okay. Now, how compact is your code? It is not a function of the rung or the line. It is a function of how the program is nested and so on. So bottom line is, what's the file size? Is it 14 MB, 18 MB, or 37 MB, or whatever? Okay. Is file size can be evaluated on the basis of the length of the program can be evaluated by the file size. Okay, I am going to show you on the PLC all these whatever I have used in the lecture keystroked, and to show you that they all work. Now the last slide. Bottom line of all PLCs is from top to bottom. Scan a number of lines or rungs based on what each rung or a line has been set to do. Set the outputs accordingly. And these rungs or lines can also contain timers, counters, and whatever as inputs as well as outputs. Counters can be up or a down or a up-down counter. You can also have analog to digital converter attached to PLC to convert a binary data into an analog output. We don't have that. Okay. Then you've already seen the use of a software to program a PLC as opposed to handheld plugged into the PLC teach pendant, which is not going to give you that much flexibility. Plus, if you program using teach pendant into a PLC, you have no way of storing those programs. The next time around, you still have to do the same keystroke of all the programs. That era is gone now. Everybody is using software where you can upload, download both ways and store your programs for future use. Different manufacturers use different software. It's like not one SolidWorks, which is kind of dominant in the CAD world. Here, everybody has their own software, and there is no unifying software. Okay, so if you buy an IDEC, you got to buy their software. If you buy a Omron, you buy their software. If you buy an Allen Bradley, it's a different software. One is not compatible with the other. And they won't make it compatible either because that's a bread and butter. But the principles are, if you have taken my course, you know what is involved. That's basically what is involved in every PLC with a little bit of a variation that is specific to that PLC. Last bullet, teach pendant personal computer-based programming with the interface for linking PC and PLCs are all there. Plus, nowadays, an added advantage or added feature is networked PLCs. That means I can buy 25 IDEC PLCs and link them all through a network so that I can control a shop floor on one side of the industry and another island on the other side, all controlled from one central node. Okay, and as I've been saying, the oodles of counters, oodles of timers, and oodles of internal outputs are available far beyond what you might even use. So there is no limitation at all. Okay. Now, the last problem that I'm going to finish on this section. You're all familiar how the elevator works. There is a motor right at the top floor. There are cables and so on that is pulling up or down your elevator module. Okay. So when you press the button from the main floor to go to 5th floor, yeah, obviously you're pressing a button from the outside and the shaft comes to you or the console comes to you. You step in and you press wherever you want to go, right? Now, what you would find is the elevator doesn't start at a high speed automatically. It starts, ramps up, and reaches a certain high speed. Some elevators would start at a standard speed right from the beginning itself. But when it reaches the destination floor, okay, you don't brake all of a sudden. It starts slowing down a few seconds before the destination, then starts inching away and locking up to the floor level before it opens the door. All this is dynamics. Basically, if there are 1,000 pounds inside, you don't start at a high speed and break everything due to momentum and so on. Very similar principle. If you have seen the rail cars being hauled these days, it is no longer one locomotive hauling a set of 30 cars. It's these days sometimes it goes a mile and a half, and they have 4 or 5. I've seen up to 5 locomotives hauling, sometimes 2 up front, 2 in the middle, and 1 somewhere, or all 5 in the front, or all 4 in the front. Okay. Now, It is well known that trains can't stop instantaneously. If you are crossing a level crossing, you want to take the chance and you jump, well, the train is not going to stop because it takes about possibly half a mile before it will stop, even when the brakes are applied. Same way when it starts, there is so much of force that is going to come into the coupler because it's hauling a huge load. It ramps up at its own pace before it stabilizes. Okay, there's all kinds of complex computer controlled in them, especially when they have 5 locomotives. You got to synchronize the speed, and not all 5 locomotives will be of the same specification. So wheel speed has to be balanced. Now, taking that scenario, I'm going to apply this to a simple conveyor. And the conveyor has to start at a low speed first, no matter what, whenever I press a button to start. Then after it reaches a certain speed, in this case, you press another button to push it to the high speed. Okay, and then you stop it using another switch or button to stop the line. So not a perfect model because I'm starting at from a dead rest, ramping up to a certain steady state. Okay, and then I'm pushing it up to high speed. But when I want to kill the system, I'm stopping instantaneously, not good. So assume that we have to have more inputs to bring the conveyor to a stop from a high speed. But let us look only at the first phase. So what are the inputs? In this case, I'm going to assume 3 switches, which are marked as X10, X11, X12. Momentary, that means if you press it, push it all the way, the signal is sent to the PLC. When you release your hand, boom, the signal is gone. So it's a momentary on, off for all 3. Makes a big difference in terms of how the control will work. So we have an X10, an X11, and an X12 as the 3 inputs. And we have 2 outputs. No output means stand still, so I don't need to have a variable. The first is Y1, which is a conveyor running at low speed, and Y2, the conveyor running at high speed. Okay, so I'm giving you just a solution. You can go through logical problem solutions, truth table, whatever. But here I want to point out how the truth table has to be modified. Okay. First, I give you the solution. First rung, what does it say? X10 or Y1. X10 is to initiate the conveyor to go at low speed, or Y1 if the conveyor is already running at low speed, so there is an OR operation. Then and not X12, that means you have not pressed the stop button, and not conveyor being in high speed Y2, then set the conveyor to go at a low speed, LS. Okay? So this is the way you would get the conveyor going at low speed. So when I press X10, it becomes 1. Y1 would have been 0. Okay, at the start, this would be okay. Okay, at the start, x1 is 0, y1 is 0. Okay. x12, it is not operation, so what would it be? It would be a 1. y2, not. This would be a 1. Okay, so when you look at this, if this is not complete,
Dr.
this is
Bala.
not yes. Yep. Somebody said something? No? Okay.
Sorry, we can't see
You can't see what?
the screen.
My microphone is okay.
Can't see your screen.
Can't see my screen. Okay. Share content. I shouldn't have to do this, but let me do this. Okay, can you see my screen now?
Or yeah, it says it's starting.
Yes?
I can't see it.
How about somebody else?
Well, we can, or at least I can see the home PowerPoint screen, but it's very confusing. There's like another sort of tab open showing your slide. It's glitching sort of, yeah.
In my screen is only one that is open.
For me, it's just showing starting.
Okay, let's try it once more. Today is not a good day. Now I totally lost. Frustration. Okay, if it doesn't come now. I see right now I've reinitialized. You should be seeing the conveyor control.
Eyes.
Yes or no?
I can't.
Somebody else?
Oh, I can't see anything. I cannot see anything. It's
Okay.
the screen still
I
look the
cannot
same.
see either.
Okay, I have no idea what the hell is gone wrong. Yeah, I'm gonna get another. What do you see now?
You win.
Now we
I
can
need
see
work
it.
now.
You can see the ladder logic?
Yeah.
Okay. I'm going to come back to that conveyor control. I don't know, something got screwed up with the PPT file. Okay. Now, I've already written this 3 examples, not written, ported them into the wind loader. The ventilation case study, which we did way about a couple of weeks ago, followed by the furnace and the conveyor. Now, this one is the ventilation. What is the problem? The problem is if the power is applied, the process must start. Something very similar to the project number 3, but not that many bells and whistles. When the process is started, okay, the process must keep going as well as the fan must come on. But if the power goes down, you activate a timer, the process goes down right away, but the fan must keep continuing to go on for another 5 seconds. So we analyzed this problem, and I have now transported that logic into the wind loader. So I am now going to simulate, okay, the problem so that you can see whether this stuff. Why is everything today shadow boxing with me? My mouse is not behaving right. Okay. Okay, I got it going. You see on the screen, whatever that is not supposed to be or should be true is in green. Okay. Now I am going to go and click on the power. If I can get my mouse to lock there. What the hell? My mouse is not even going anywhere. My apologies, guys. I don't know what is going on. Okay. Are you seeing the screen with the WinLoader now? I got it back. So I'm going to apply the power. What should happen? The process starts. The fan is going. Process and fan are on. I'm using an internal output which is not on. Everything else is going. Now what I'm going to do is to kill the power. Okay. Watch the timer. It's counting down. The fan is still going on. And at the end, the process and the fan have died. Okay. So let's repeat this. I'm applying power. Everything is normal. Process is on. Fan is running. Now I am going to kill the power. Okay. And I am going to reactivate the power. I changed the scenario. Okay. I'm going to kill the power. Before the 5 seconds has elapsed, the fan is still on. I caught up and the fan continues to be on. Now I'm going to kill the power. Okay, the timer is counting. Power was not restored. The fan is still on. Process has already got killed. And fan is also now killed after 5 seconds. So this is a straight transfer of the equations or the process that I did in the lecture transported to the PLC software. Now let's take the next one. Before I take the next one, I gotta kill the simulation. Okay. Next one is the furnace control. Okay, I hope I don't have to share the screen. It's still on. Yes.
Yeah.
Okay. So this is the furnace control. So what I'm going to do is get it back into simulation mode. So it's on simulation mode. Power is going to be applied. Everything is off. The gas valve is closed. The ignition is not there. There is no alarm. So I'm going to apply the power. Gas valve is open. Ignition came. No flame. Alarm came on. Why? Well, I discussed the problem. And now I'm going to apply power. Now what I'm going to do, the flame, I'm going to get the flame coming up. So gas valve is still open. Ignition went down. No alarm this time because the flame is already there. Okay, let's repeat it. Okay, now I'm going to kill the flame. Okay, ignition comes back, tries to ignite. No flame for 5 seconds or whatever I did. Alarm came on and continues to be on. So the ladder that I have got here is exactly what was developed in the lecture, transported into a ladder logic. And this is how I don't need a model at all. I can actually do this simulation, but be aware there are a few bits and pieces that are not going to be seen in the simulation. Best is to implement and test it. Okay, I have models for all this. Okay, now let me go into the next one, which is the conveyor that I started talking about until things went wrong with my WebEx. Okay, so now I'm going to start the conveyor at slow speed. I have to be in simulation mode. Okay, go slow, go fast, or go high, they're all off. Okay, so I'm going to hit button start slow. Okay, and then I'm going to take it off because it's momentary on, right? So the wrong one keeps the conveyor going at slow speed. I initially hit the go slow, got the upper ladder going, then I killed it because why the Q000 came on, it is now keeping the line conveyor going. Now what I'm going to do, this button is gone. I'm going to go and hit the high. Okay. So what happens? I have to kill the low speed by, I have got the high speed here, just a minute. I got to get this going because automatically it would happen. Now it is going at high speed, and the only way I can stop the conveyor is going and hitting the stop sign. Okay, let's repeat this. I got the stop sign now, not stop sign, stop switch gone. Want to start the conveyor. Something is not. This should be off. Conveyor is on. Okay. I'm doing this because it's momentary. Normally it would be like this. Gone. The moment you remove your hand, it's finished. Now I come here. Okay. Stops switch is still off. Start low. It's not on. I'm going to hit this. Okay. This should be up. Head on through. Start high. Go slow. Should be gone. Then keep the conveyor going at high speed. Strictly speaking, this is what will happen with the PLC, as would be the case in an elevator. When you want the motor to go at a slowish speed, obviously you're going to switch either phases or switch voltages in the case of a DC. So you will have a power supply which produces the higher voltage as well as the low voltage. Your output Q000 and Q0001 are two separate relays which are going to be activated by the PLC, but the output coil of the two relays will be wired to a slow speed and a high speed from the power supply, which goes directly to the motor. So you're basically pushing the motor from a rest by supplying a voltage which will make the motor go slow speed, and whenever it is required, stabilized, you push it to a high speed by pressing another button. In reality, in motion control, you're not going to be pressing buttons. These being in low speed and being in high speed is going to be sensed by sensors. Okay? The sensor will tell the PLC, yeah, I have reached the low speed. Now push it to the high speed. Then that sensor goes, it is not anymore effective. The other sensor will kick in and take it all the way to the high speed and maintain the motor at the higher speed. That's how it will go. Okay. So I given you 3 examples. I will give you more as I move on. But today I am going to close this now. Okay, do you see my PowerPoint now shifted to something else?
Yep.
Good. Right. Okay. I asked you upfront whether you all know Carnamap. I think I got the answer that nobody aware of it. Okay, Karna map is a powerful tool which you're going to see.
Doctor.
Yes, yes. Can't see the slide. Anybody else? Can't see my slide.
I can see the slide.
I
Okay.
can also see the slide.
Okay, you see the Karna map? In the sense the title?
It's probably just mine.
Okay. So Karna map is a very powerful tool. There are many other tools. In fact,
Well, actually, Dr. Bala, now I can't. I was able to at one point, and now I can't.
it is the transmission WebEx. I have my screen and I don't even know what else I can do. If it is intermittent, maybe there is some problem with the internet. Okay, I am on hardwired internet.
Oh, never mind. I fixed it.
Okay.
All right.
Okay. So Karna map is a powerful tool that you can use to solve the PLC problems. There is also Petronet, which is more advanced, more research tool, but can do the PLC problems. I'm not going there. Only 1 year I have gone because of 5 students in my class who came on an exchange program from France, who had taken a little bit of the Petronet. So for the benefit of everybody else, I covered it. Now, Boolean algebra is pretty good. We have seen, analyze all the problem, okay? But when you have number of variables, for example, 5 inputs, it starts becoming bigger and bigger and bigger, okay? The truth table. So is there another tool? Of course, we know if you have 5, 6, 7, 8 is to segment the problem. But Karna map up to 3 is not a problem at all. It will use a different technique in order to analyze the problem. Okay, so the Karna map technique uses graphical principles, graphical analysis, and brings together logical terms that are adjacent to each other as a complement. Simple example, A and a B, if it is adjacent to A and not B, B is going to be eliminated, becomes an A. So it uses the simple principle as well as few others which you are going to see in order to analyze. It uses the law of complements and the characteristic theorem. Law of complement uses the principle A or A naught is 1. Characteristic theorem, A and a 1 is an A. In this case, I've just put distinguish X and a 1 is a X. Okay, so how would I use these two expressions in the Karna map as a technique in order to move on? So I've already covered the slide. If you can group together two terms which have a complement, we can eliminate, but I'm going to show it in the graph, okay, how this is going to work. So Karna map can be, if you have, let me back off a bit, you're not going to get away from problem analysis, identifying the variables, problem analysis, and then instead of going truth, yeah, you have to go to truth table, but you're not going to write the equations from the truth table. Okay, the decision making is still yours, still the designer's. He or she decides for this row, this output should be turned on. Then, instead of writing all the equations and then trying to compress them using Boolean logic theorems, Karna map is going to kick in. So that's the stage at which Karna map comes in. So basically, you are going to bypass use of theorems. Okay. Now, instead of reading the last one, I will take the diagram. Now, let's take this simple expression. An output A, not A, an output X must be generated. And according to your analysis or my analysis, somebody's analysis, the equation turned out to be A and not B, or A and B. That's how the expression came out. And by using standard Boolean logic, you will come up with a very simple expression X equal to A. The B and B naught using characteristic theorem will get knocked off. Okay, but can this be the same decision can be reached using Karnaugh map? Okay, let's see. The Karnaugh map is boxes of rows and columns. So in this case, I have 2 rows and 2 columns, a 2 by 2 grid. Now you look at the grid here. The first box at the top, which is on the row 1, column 1, is marked as not A and not B. The next column on row 1 is marked as not A and B. Different. Now go to the second row, column 1, is A, not B. Okay, different again. And the one next to it is AB. Now, if you translate all this into binary zeros and ones, what would be row 1, column 1? Would be 0, 0. Correct? For A and B. The next one is 0, 1. And the one below is 1, 1. And the row 2, column 1 would be 1, 0. So you have 0, 0, 0, 1, 1, 0, 1, 1, filling up the 4 boxes of the grid. Okay. Now, this is one kind of a Karnaugh map. Different people use it in different ways. For my course, this is it. This is what you're going to follow. The makeup of the Karnaugh map for a 2 variable. In this case, it's 2 variable A and a B. So I got a red A and a green B. Okay. So if you look at it, the first box is 0, 0 for A. The second row, A is 1 in both. Okay. And if you look at B, it is 0 in the first box. And where else it is 0? It is 0 on column 1 or row 2, column 1, and row 1, column 1, where B is 0. So if you look at the way I have made it, A is 0 along that row, or on the second row where it is marked as 1. B is column 1 is 0, and B is 1 along column 1. Now, what's your equation or raw equation? The raw equation that came up from truth table is X equal to A not B, or A and B. Now, these 2 terms are there in your map. Circle them. In this case, I've used a red box around the expressions that are adjacent to each other. If you find 2 expressions adjacent to each other, right away, complement theorem will apply. X equal to A. Okay, so in this case, it's not a big deal, but it came out nice and clean without any issue. As the problem becomes more complicated, you will see the advantage of Carnamap, which I will tell you in the next class. Am I going past the time? Yes. Alarm never came. Okay, so we stop here to finish off. I am holding a lab this afternoon. I have all the files that you submitted, which are with me. So what I'm going to do, one by one, whoever who is there, I'm going to move you into a separate discussion room and show you your files to see where you have problems. There may be more problems. I have not gone through every one of them. So I want you to correct, update, and send me the file, which is the one I will use to cut your part. When I cut your part, obviously, I want you to be in the lab. So I am hoping, which I will ask this afternoon, whether any of you are free next week from Monday through Friday. Then we can, it will take a maximum 1 hour if everything goes well. Okay, so we'll talk about it this afternoon. Okay, any questions before I close? Sorry about all those boo-boos today. I have to make sure everything worked right this morning, but not sure. Okay, so I am going to stop sharing and leave.
Actually, Bala, so do you want the BO2 members to join the BO1 today, or is that we're gonna do that on our own time?
There are 3 hours. It will take me 10 to 15 minutes each, probably. But if you are joining in the BO2, the number of computers may become limited. You can't do much beyond that. So if you are in BO2, stay in BO2. If it is, you're free.
Yeah, okay, so we'll see you on Thursday then.
Yes.
Okay, thank you.
Anybody else?
Hey, Dr. Bala, are you able to post these slides? I wasn't able to, I don't
The
know, I was
last,
trying to join on other devices and I wasn't able to see.
yeah, this last one that I started today is not there, but I will go this afternoon.
Sounds good. Thank you.